Hello students, myself Professor Ashok M Jain. In this lecture number 7, Unit 1, I am going to talk about network equations based on the node and basis, that is nodal analysis technique. This technique is based on KCL. So I am going to talk about the KCL, okay? And after studying this presentation, you will be in position to understand the concept of nodal analysis. What is the KCL? This KCL is applicable at the point or junction, right? This is the point or junction. So what it says, at any point or junction or node, the sum of incoming current equal to sum of outgoing current. That is the KCL. Okay. If you want to explain it, you can draw one figure and you show the direction of current. So you can say this I1 is incoming, I2, I3, I4, all three are outgoing. So we can say, as per the rule, I1, that is incoming current, equal to outgoing current, I1 equal to I2 plus I3 plus I4. That is the KCL. Already we have studied this in earlier slide, earlier presentation, right? Now I am going to talk about the nodal analysis. What is a nodal analysis? See here, this nodal analysis or node voltage analysis, the other name of this method is node voltage analysis, right? So this method is applicable, this method is based on the KCL, Kirchhoff's current law, okay? This is based on the KCL, right? So what we have to do, we have to find the node voltages, okay? And how many nodes are there? This, you can say this is one node 1, this is node number 2. So with the help of this method we will find the node voltages, and accordingly we can find the current through any branch. So in this network, how many nodes are there? 1, 2 and this is 3, that is connected to ground, right? These are the 3 nodes. With the help of this method, we can find the current through any branch, or you can find the voltage of any node. The beauty of this network is what? With the help of this network, we have to solve one equation less. Means, suppose you are going to solve the problem by KVL. So we have 3 loops, loop 1, loop 2, loop 3. Clear? So you have to solve three equations. But here, how many nodes are there? 3. 1, 2, 3. Out of these 3, one connected to ground. That is called as a reference node, right? So reference node का potential क्या होता है? 0. Why? It is connected to ground. So we know the potential of ground is 0. So इसका अगर आपको पोटेंशियल मालूम है तो यहाँ इक्वेशन लिखने की जरूरत नहीं है, बस ये दो यहाँ पर 1 and 2 we have to write 2 equations. So इसका मतलब ये है you have to write number of nodes जितने, उससे one equation कम लिखना पड़ता है, n minus 1 equation will be required. So this will become more simple. अगर 4 लूप का प्रॉब्लम है तो 4 लूप बनेंगे, KVL से करेंगे, लेकिन सेम प्रॉब्लम अगर आप KCL से करेंगे तो it will require only 3 equations, not more than that. Okay, so that is the beauty of this network, nodal analysis method. Now what are the steps? Steps क्या है? पहला step क्या है? What are the steps? First step is that draw the simple circuit. It is given already. Okay, first step is what? Give the name to each junction. Give the name to each junction. कितने junction है? एक junction है ये. This is second junction. Give the name to each junction. Let us say V1 and this is 2. Give the name to junction, right? Second, assign the voltage to each node. इसको assign करो voltage V1. इसको assign करो voltage V2. V1 and V2. Assign the voltage to each node, right? We have actually 3 nodes, 1, 2 and 3. But 3 current to ground, connected to ground. So इसका potential क्या है? 0. So other than reference node, we will assign the voltage V1 to this node, V2 to this node. Third, remark the current to each branch. Remark the current to each branch. This is the current I1. You can remark in this way. Let us say I2. Sorry, I2 यहाँ remark किया है ऐसा ये. okay, in this way. So don't remark here, इसको I3 remark कर दो, let us say I4. Okay, so remark the equations I1, I2, I3, I4, right? Fourth step क्या है? Write the KCL to each node except the reference node. So KCL at node 1. What is the KCL at node 1? I1 incoming equal to outgoing, I3 outgoing and I4 outgoing, I3 plus I4. That is the KCL, and based on this KCL we will solve it, right? KCL at node 2. What is the KCL at node 2? I2 incoming है, I4 is also incoming at this node 2. So I2 plus I4, these two are incoming current, right? These two, I2 and I4, both are incoming at this node. And sorry, यहाँ पर remark नहीं किया था, sorry, I5. So what is I5? Outgoing. I5 outgoing. So I got the equation I2 plus I4. These two are incoming equal to I5 is the outgoing. So in this way you can write the equation. Clear? So node voltage method is very simple. पहला काम क्या करना है आपको? We have to assign the voltage to all nodes except the reference node. Second step क्या है? Next step क्या है? Remark the current through each and every branch. Each and every branch, whatever the branches we have, remark I1, I2, I3, I4, I. Direction, whatever you want you can take, and accordingly equation we will write. Next step क्या है? Last step, we will write the KCL at node 1 and KCL at node 2. We will not write the KCL at node 3. क्यों KCL क्यों लिखते हैं? क्योंकि ये नोड वोल्टेजेस निकालना है V1 and V2. अगर मान लो V2 मालूम होता तो यहाँ KCL लिखने की जरूरत ही नहीं है. याद रखना KCL लिख के क्या करते हैं? नोड वोल्टेजेस निकालते हैं. अगर एक पर्टिकुलर नोड का वोल्टेज मालूम है सो नो नीड टू राइट. मान लो यहाँ सपोज करो सोर्स होता, सपोज करो यहाँ सोर्स है, फॉर एग्जांपल सपोज करो 10 वोल्ट सोर्स है यहाँ, दिस इज प्लस में, तो ये यहाँ का पोटेंशियल क्या है? ग्राउंड. सो यहाँ का कितना हो जाएगा? ग्राउंड 0, यहाँ का 10, सो V2 कितना है? 10. क्लियर? सो V2 मालूम है, सो यहाँ KCL लिखने की जरूरत नहीं है. ओनली वी विल राइट द KCL एट दिस नोड 1. That is the beauty. Automatically, if the node voltage is मालूम है, automatically number of equations कम होते जाएंगे. Be careful about it. Okay. So I am writing. This is the node voltage analysis method. Now I am going to solve one or two problems based on that. Okay. So I'm going to solve the problem, one or two problem based on this nodal analysis. Okay, this is the example number 1. Find the current through 6 ohm resistance, this 6 ohm resistance, right? Okay, by nodal analysis. What are the steps? So what are the steps we will follow? First step क्या है? Assign the voltage to all nodes. This is the node. Assign the voltage to all nodes. V1 I am assigning. Is it node? Yes. Assign the voltage to V2 here. यहाँ का अगर ये रेजिस्टेंस 10 ओम शॉर्ट होता नहीं होता तो वोल्टेज हियर 20 है तो यहाँ भी 20 होता, बट इट इज देयर, सो इट इज V1 and V2. And third node connected to ground. This is connected to ground. So how many nodes are there? Actually total number of nodes are 3. 1, 2, 3. But this connected to ground. This node is connected to ground. So यहाँ का potential. What is the potential of this node? 0. We have two nodes. Okay. Next step is का remark the current through each and every branch. Whatever the direction you want, you can take, but you have to remark. So I am remarking the current I1 here, I2 here, I3 here, I4 here, I5 here. अभी जैसा आप बोलें, जैसा डायरेक्शन बोल रहे हैं, लेट अस से इन दिस वे I5. So whatever the direction you want, you can take, but you have to remark current through each and every branch. I remark I1, I2, I3, I4, I5. Right? Last step क्या? Write the KCL to each node except the reference node. So we will write the KCL at node 1. We will write the KCL at node 2. Clear? So we will get two equations. So KCL at node 1. What is the KCL at node 1? Incoming current equal to outgoing current. What is at this node? Incoming current क्या? I1 equal to I2 क्या है? Outgoing. I3 क्या है? Outgoing. So equal to I3 plus I4. These are the two outgoing current. Now what is the incoming current? I1. I1 देखो यहाँ का what is the potential this point? 0. What is the potential of this point? 0. What is the potential of this point? 0. So what is the potential of this point? 20. यहाँ का वोल्टेज कितना है? 20 वोल्ट. So I1 क्या होगा? Potential difference from Ohm's law. What is the value of I1? Potential difference divided by resistance V by R. V कितना है इन दोनों का difference? 20 minus V1. भाई आपने V1 minus 20 क्यों नहीं किया? We can take V1 minus 20 also. See the direction. Current is going in this way, and we know current flows from higher potential to lower potential. That's why I had taken 20 minus V1 upon 10. I3. What is the value of I3? This V1 minus V2 upon 6. This 6 plus I4. What is I4? This I4. Sorry. I1 equal to I2 plus I3. Sorry, this is I2. Please correct it. Sorry, it is KCL at this node. I1 incoming, I2 और I3 outgoing. So I2 कितना होगा? I2 V1 minus 0 upon 8. So V1 by 8. I am taking LCM common of both side. कॉमन LCM ले रहा हूं एंड LCM ऐसा लेना है इट शुड बी डिविजिबल बाय ऑल. इट शुड बी डिविजिबल बाय दिस. क्लियर? आई थिंक इट इज 120. यस, तीनों का मल्टीप्लाई कर दो वो भी चलेगा, वैल्यू ज्यादा बड़ी आएंगी. या यू कैन टेक 120, वट एवर यू वांट, बट इट शुड बी डिविजिबल बाय ऑल. आप 120 ले लो, 240 ले लो, 480, 6 into 4, 8, 48 into 10, 480 भी ले सकते हो. That is correct. Anyway, so कैसे करेंगे? How to do it? 120 upon 10. 120 upon 10 कितना आएगा? 12. 12 into 20, 240 minus 120 upon 10, 12 into V1, 12 V1 equal to 120 upon 6. 120 upon 6, 20 V1 minus 20 V2 plus this plus 120 upon 8. Yes, 120 upon 8 is 15 into V1. Okay, so this is 20 V1, this is 15 V1, 35 V1 और माइनस वहां से जाएगा 12, सो यहां हो जाएगा 47 V1 दिस साइड. क्लियर? माइनस 20 V2. ओके, इक्वल टू यहां क्या बचेगा? सिर्फ क्या बचेगा? सिर्फ 240. This is equation number 1. I got it. Okay, so I got equation number 1. LCM लेने के बाद इक्वेशन आने के बाद 120 का कोई मीनिंग नहीं रहता, जरूरत नहीं है. ओनली दिस इक्वेशन, राइट? KCL at node 2. KCL at node 2. What is the KCL at node 2? At this node you can say I3 is incoming, right? I3 क्या है? इनकमिंग. एंड I4 और I5 क्या है? आउटगोइंग. सो आई विल राइट द KCL I3 इक्वल टू I4 प्लस I5, राइट? I3 incoming, I4 or I5 outgoing. So I3, what is the value of I3? V1 minus V2 upon 6. V1 minus V2 upon 6 equal to, what is the value of, hello, stop! What is the value of I4? I4 equal to what? This I4, V2 minus 0 upon 4. V2 minus 0 upon 4 plus, what is the value of I5? V2 minus this potential. What is the potential of this point? 0. What is the potential of this point? 0. What is the potential of this point? 10. So what is the value of I5? V2 minus 10 upon 2. V2 minus 10 upon 2. Okay. V2 minus 10 upon 2. Right. Now common LCM. What is the value of common LCM? I think it is 12. It should be divisible by all. Okay, 12. So 12 upon 6. You will get 2 into V1. 2V1 minus 2V2 equal to 12 upon 3. Sorry, 12 upon 4. 3. 3 into V2. 3V2 plus 12 upon 2. You will get 6. 6 into V2. 6V2 minus 660. 6 into 10 60. Okay, so आपका इक्वेशन आ गया. So 2V1 minus 2V2 और ये 9V2, ये और ये 3 और 6 9V2 इधर जाएंगे तो माइनस 9V2 minus 2 minus 11V2 इक्वल टू क्या बच रहा है? minus 60. This is equation number 2. 2V1 minus 9V2 equal to minus 60. Right? I am getting these two equations, this and this. You can solve the problem by simultaneous method. You can solve the problem by Cramer's rule. You can use calculator and you can solve it. So if you are going to use the calculator, just see here. If you use the calculator, if you press the mode, again press the mode, again press the mode, you will see on the monitor EQ and equation आ रहा है, because we have to solve the equation. And if you see there, it is written there 1. So press 1. You will get unknowns are there. Select the unknowns. How many unknowns are there? 2. V1 and V2. So select 2. Then you will see there on the monitor A1 is showing. A1 is what? A1 कितना है? देखो 47. 47 A1 है. So press 47. If you press equal, you will see there on the monitor B1. B1 is what? Minus 20. So press minus 20. If you press equal, you will get C1. C1 कितना है? 240. This 240. C1 is 240. 240. If you press equal, you will get A2. A2 is what? 2. A2 is 2. If you press equal, you will get B2. You will get B2 minus 11. Minus 11. Minus 11. If you press equal, you will get C1. कितना है? Sorry, C2 कितना है? Minus 60. If you press equal, you will get X. X is nothing but V1. So on with the help of calculator, I am getting V1 equal to what? 8.05 volt. And again press equal, you will get Y means X V2. कितना है? 6.91 volt. I got V1 and V2. Right? Now, what is your question? Find the current through 6 ohm. अगर उन्हें V1 V2 पूछा होगा तो it is okay. Find the current through 6 ohm. 6 ohm मतलब current through 6 ohm is what? I3. And you can say I3 is what? I3 is what? V1 minus V2 upon 6. You can say I3 equal to what? V1 minus V2 upon 6. So I3, that is the answer. V1 8.05 minus V2 6.91, V1 minus V2 upon 6. That is the answer. 8.05 minus 6.91 equal divided by 6. I am getting answer 0.19 ampere. 0.19 ampere. That is our answer. Okay, so in this way you can solve the problem, right? So it is very simple. पहला काम क्या करना है? You have to assign the voltage to all nodes except the reference node V1, V2. Then remark the current through each and every branch. Then you have to write KCL at node 1, KCL at node 2. Okay, you will get two equations, and with the help of calculator you can solve it. ठीक है? Now I'm rubbing it. I'm taking one more problem. Okay. Example number 2, I'm going to take find the current through 2 ohm by nodal analysis. Current through 2 ohm just here. Current through 2 ohm. Clear? So what are the steps? First step, these are the nodes. Assign the voltage to this node. Clear? Can I say 20 volt here? Yes. ये suppose this point connected to ground. So what is the potential here? 0. यहाँ से यहाँ rise हो रहा है, तो यहाँ का voltage क्या है? 20. Similarly ये 0. यहाँ का voltage क्या है? 30 volt. Clear? अगर ये पूछा होता current, find the current through 4 ohm, so it is very simple. 30 minus 20, 10 upon 4, 2.5 ampere आ रहा है current through 4 ohm. 30 minus यहाँ का potential कितना? 20, that is 10 upon 4. But they are asking find the current through 2 ohm by nodal analysis. So assign the voltage to all nodes. 20 volt, यहाँ 30, यहाँ assign the voltage, let us say V. Yeah, V1. Let us say V1. Okay. Next step is what? Write the KCL. Sorry, before KCL you have to remark the current through each and every branch. यहाँ resistance नहीं है ना, reactance नहीं है, capacitance नहीं है, so no need to draw the current. Clear? We will remark the current here. Say I1, say I2, say I3, say I4. जहां जहां रेजिस्टेंस या रिएक्टेंस है, we will remark there only. No need to remark here. Why? There is no resistance, no drop. Here also there is no resistance, no drop. Right? So we will remark here I1, I2, I3, I4. आप चाहो तो नाम बदल सकते हो, डायरेक्शन बदल सकते हो, whatever you want. Now we will write the KCL. Okay? Add. कहाँ लिखेंगे KCL at this node? No. Why? यहाँ का वोल्टेज, इस नोड का वोल्टेज मालूम है 20. No need to. What is the purpose of writing the KCL? The purpose of writing the KCL is to find the node voltage. It is already known. यहाँ का already मालूम है, यहाँ का नहीं मालूम. So we will write KCL at node 1. Only one equation बनने वाला है. How many nodes are there? 1, 2, 3 and this is reference. तो 3 equation बन सकते थे, but यहाँ का equation मालूम है. यहाँ का voltage, this voltage is also known. We will write the KCL at node 1. What is the KCL at node 1? Incoming current equal to outgoing current. What is the incoming current? I1 at this node equal to outgoing current क्या है? I2 plus I3. Right? At this node I1 is incoming, I2 outgoing, I3 outgoing. Right? So I1 equal to I2 plus I3. What is I1? Potential difference 20 minus V1 upon 2. Is it clear? Potential difference कितना? 20 minus V1. क्योंकि current always flows from higher to lower. So this is higher, this is lower. So 20 minus V1 upon 2 equal to I2. What is I2? This I2. This I2. So V1 minus 0 upon 5. So V1 upon 5 plus I3 कितना है? This I3. V1 minus 30. V1 minus 30 upon 3. LCM, common LCM. I think common LCM is, it should be divisible by all. 15 into 3, 15, sorry 5 into 3, 15 into 2, 30 I am taking. चलो 30. Now 30 upon 2 कितना होगा? 30 divided by 2, 15 into 20. 15 into 20, 300. Minus 15 V1 equal to 30 by 5, 6 आएगा. 30 by 5, 6 into V1, 6 V1 plus 30 by 3, 10 into V1, 10 V1 minus 30 by 3, 10 into 30, 300. Right? So I am getting, this is यहाँ जाएगा. So I am getting 0. Just wait, some confusion is there. I1 equal to I2 plus I3. I1 is 20 minus V1 upon 2 equal to V1 by 5. Okay, plus V1 minus 30. V1 minus 30 by 3. LCM 30 लिया, so 30 upon 2, 15 into 20, 300 minus 15 V1 equal to 6 V1 plus 10 V1 minus 300. Okay. So कितना आएगा ये इधर जाएगा. So 15 plus 16, 31 V1, right? 16 plus 15, 31 V1 equal to, ये 300 इधर जाएगा तो प्लस हो जाएगा. So it is 600. So what is the value of V1? 600 upon 31. Okay, I am going to use the calculator. 600 divided by 31. I am getting 19.35. 19.35 volt. That is the answer. Now, I have given find the current through 2 ohm. So current through 2 ohm is what? Current through 2 ohm is I1. So current through 2 ohm, that is I1 equal to what? I1 equal to get 20 minus V1. 20 minus V1 divided by R2. So 20 minus V1 कितना? 19.35 upon 2. So 19.35, okay. Minus 20 divided by 2. So I am getting minus plus 0.3225 ampere. That is the answer. 0.322 ampere. Okay. So that is the answer. Okay. So in this way you can solve the problem. Just you have to find the number of nodes, remark the current through each and every branch. और अगली स्टेप क्या है? We will write the KCL at the node whose voltage is to be find, right? And then find the required quantity. So I am going to rub it. Okay, so this is the way. I'll take few more problems based on the KCL later on. Okay, and some these problems will be based on the KCL, which is consisting of dependent source. So I'm going to thank you very much for listening me carefully. Thank you.